Today, we're probably going to talk a little bit less about Risoyo specifically and a little bit more about the, and I think my screen is not showing. So let me, I don't see it up there. Oh, okay. There we go. Um, and so let's talk a little bit about that and kind of about where things are going with AI. It's been a huge topic among the development community. I don't know if you spend much time on x.com, which is where a lot of developers actually spend a fair amount of time. And there's a lot of talk about what the impact of AI will be. Is it going to blow up the whole industry? Is it just going to make everything wonderful? Or is it going to be business as usual? So let's do our best today to answer that question. Just a little bit more about me. I am a developer and an entrepreneur and have been helping companies both in e-commerce and in software development in general. So our company, Risoyo, is about split 50-50 between e-commerce development and the implementation of web applications and other types of applications for the internet. I speak several languages and spent a fair amount of time. In fact, started my career in Europe and have since moved to Dallas. And I am very much a family man and very happy about that. Uh, the one thing that I'd say about my career is while I started in Europe, when I came back to the States, I worked for PepsiCo and a couple of other large corporations, both in marketing and in marketing management. And then this happened one day. I got really frustrated, and this is actually not me. I got really frustrated with my career and the company that I was going with, and I just quit. I just walked up, left. I don't recommend this as a career move by any means. But I would say that for me, it ended up in a happy place because then I left there, and in a couple of years, I had founded Risoyo, and we were working in the very exciting e-commerce business, and I love that business to this day. We do a lot of work in there, but it really was a big change in my life, and that's how I got into tech to a certain extent. Um, so let's go back to our our premise here: Armageddon, utopia, business as usual. I can immediately eliminate one of these. There is no utopia. If things get really good, then that just increases the basis of competition in business. So I'm really only going to address the Armageddon or business as usual as a thesis as we go throughout the rest of this presentation. And let's talk about the road to LLMs. So I think I'm going to kind of open up the little chat bubble so I can see kind of what's going on in chat, I think. There we go. So I'm going to show you a quote, and I'd like for you to tell me who you think made this quote. So just like pop it up in the chat if you can. And oops. And I will read this quote to you. And well, it clicked ahead. So things happen fairly slowly. They do. These waves of technology, you can see them way before they happen. You just have to choose wisely which ones you're going to surf. If you choose unwisely, then you can waste a lot of energy. But if you choose wisely, it actually unfolds fairly slowly. It takes years. So anybody have an idea who that was? Drop it in the chat if you do. I'll give you a few seconds to think about who might have said this quote. Let's see. Hey, yeah, got a lot of people in there got it right. Maybe you're Googling it. I don't know, but yeah, this was definitely Steve Jobs. Anybody have an idea what he was talking about? Like what he was referring to in this particular quote? It was a specific technology. So think about it for a second. Somebody said phones. Anybody else care to? Yeah, definitely Steve Jobs, software, internet. So Mac OS. Yeah, the phones was actually correct. He was talking about the iPhone. This was a quote from 2008 where he was being interviewed about the launch of the iPhone, which came as a surprise to many businesses. But that is where he weighed in for it. So yeah, somebody got 2 for 2. But if that's true, I mean, it seems to me, and I think a lot of people would make this comment, that much of what's going on in AI has come on like just over the past few years. So let's talk about like what that slow development was from the decades of development in artificial intelligence was. Artificial intelligence on its own, we'll just leave that term where it is. A lot of people in the industry don't like that term. There's a lot of problems with it, but I think it's sort of what people commonly call this field. And I'm going to draw a line in 1951 uh, between when people were talking about artificial intelligence and when artificial intelligence development actually began to happen, when it became a real thing. And I'm going to go back 100 years from today uh, to talk about this Rossum's Universal Robots, which was a play written by Karel Čapek, who was a Czech playwright. And he was written in 1920. It was first performed, I think, in January of 1921, but it became very popular. It was translated into 30 different languages. And one of the, I guess, claims to fame in modern day lore is that this was the first use of the word robots. And robots came from a Czech word, and I'm probably mispronouncing it, although it should be pretty close. I think it's robota or robota, which referred to a type of serf in a Czech culture. So, almost slave peasant. And this company was making ones that were aware and that had intelligence and that could think for themselves. So they went straight from they skipped the entire internet and just went into having robots with artificial intelligence built into them. And the one thing that's very interesting about this play, which is available on YouTube, is that it foresaw a lot of the problems that we actually have in artificial intelligence, and some of the successes and some of the failures. And there's a lot of stuff going on. It foresaw some of the effect of automation in general on human society, the hubris of the business world, some of the good and bad governance that might come from having intelligent uh, aids, if you will. And so I promise if you watch the play, you're going to recognize so many of the topics and themes, despite it being 100 years old and kind of predating digital computers. But if you just look up Rossum's Universal Robots, there's a stage version on YouTube, and you can enjoy watching it. It's a good watch in my opinion. But going back to our timeline, so here we are, predictions from before the time when we even had the technology to consider the universal or to consider artificial intelligence. We were still back in the electromechanical age, and solid state relays hadn't even been invented yet. But these were some of the steps that kind of came along the way that made it possible. But you'll notice that 1951 kind of falls right in the middle of what's known as the vacuum tube era, and this was a pre-transistorized device. I'll show you one in just a minute, what they look like. But as the technology evolved and our capabilities evolved, this prediction by Ray Kurzweil talks about how different technologies have kind of supported the march toward human intelligence, or not really human intelligence, but artificial intelligence. And it's kind of interesting. This was 10 years ago, and it's been relatively, I would say, um, accurate in the fact that we really needed for the hardware to catch up with what we wanted to do with the software and how we were going to sort of implement artificial intelligence. One of the things that Kurzweil foresaw by the year 2020 back then was that we would have either optical or quantum computing or DNA computing, all of which are kind of under development at this point. But I don't think you're going to see this type of computing sort of come into the mainstream for a few years. There's still many technical hurdles to overcome. So we got to hope that those integrated circuits will continue down Moore's law for a while. I'm not sure they will. In the 1940s, so still before this time, you probably know about a man named Alan Turing, and you've probably heard about his contributions to science and to artificial intelligence. And this is actually, a photo of an image in the museum of the computer that he invented with the purpose of breaking the Enigma code during World War II, which was extremely successful and really helped the Allies. But today, when we talk about computer science and artificial intelligence, Turing is most known for a game that he invented called The Imitation Game. In fact, there's a movie called The Imitation Game, which talks about what he was doing. It focuses a lot more on his work in the war than it does after that. The movie does, but The Imitation Game actually refers to what some people call the Turing test. And the way that it works is you have a computer and a person. The computer's pretending to be a person behind a screen, and a second person, person C in this case, who's asking questions randomly of one or the other behind the screen. And this person C is considered the judge. So if the judge cannot consistently tell which is which, am I getting an answer from a human or am I getting an answer from a computer, then the computer wins a game. And some people have said that, taken that to mean, well, then we've achieved, artificial general intelligence. That was never something that sort of crossed Turing's mind. It was really more of a thought experiment of understanding progress towards smarter machines. So, coming back to 1951, these are some of the things that happened prior to that. Why did I choose that date as a starting point? And there's a very specific reason that that artificial intelligence became kind of real with a man named Marvin Minsky, he was actually an engineer, and he had worked on electronics and computers for what they were at the time. And he had seen these other colleagues of his kind of testing rats through a maze. And if you've never dealt with rats, if you've ever dealt with rats, they're very smart creatures and they make, pretty good decisions. And he says, could I come up with something automated that is a computer or a machine that would be able to do the same thing? Would it be able to navigate its way through this maze? And he actually developed a device in 1951 called and it didn't really work the way he intended to, but it was actually the first neural net. In fact, it's a very, very small neural net, but it was a simple neural net. But its output was either to tell the person whether they're going to go straight to the left or to the right when it came into opening a maze. And like I said, the machine didn't really work because it could not formulate a plan. And so its reactions kind of ended up being not much better than random instructions, simply because it was unable to learn from past mistakes. In fact, this device had no memory, so it had no memory that it had even made these mistakes. But this was the first attempt. This was the first attempt at building a neural net, at building actually, a, a device that can make decisions from its environment autonomously. And so this is really kind of the first attempt in 1951. Now, what's interesting is that despite the fact that Snark, which is what this machine was called, uh, failed to demonstrate intelligence, it sparked an enormous wave of interest in artificial intelligence that continues today. And in 1959, Minsky was invited to MIT, where he founded the MIT AI lab along with a gentleman named John McCarthy. And what's really tragic to me about his life was that at the very end of the 2010s is when large language models began to perform. They began to be very interesting. And McCarthy died in 2016. So really just before the big leap in large language models. After that, there were a couple of professors in Carnegie Mellon who developed and demonstrated the first version of a program called Logic Theorist, which successfully proved 38 out of 52 unproven theorems in mathematics. And this was the first time, as far as I know, that a computer completed successfully or competed successfully against humans in an area of real human endeavor, which was mathematics. And in 1965, a couple of Ukrainian researchers developed the first deep learning algorithm, which allowed the machine to train and is similar to neural networks of today. It used a different system than our current neural nets. It actually projected forward rather than back propagating, as is the current norm. And we'll talk about a little bit about what that means in just a minute. Then 1970 is the first autonomous vehicle. Now, this vehicle was designed to go across a room with a few chairs in it without running into the chairs. It had a computer on board. It had a camera, and it digitized the images from this camera. It took it about 5 hours to navigate across a room, but this was 1970, so we're already 50 years ago. There was a sense that we could do something with autonomous vehicles, and very baby steps, very embryonic steps in that development. The 1990s, 1980s, not a lot going on. There were things going on, but in the 1990s, computing power really began to catch up with these fantasies that we had, like this dreaming about AI that we had, and we were starting to see some really incredible successes. So 1997, this machine here, which was known as Deep Blue, finally defeated the world chess champion Garry Kasparov after having just had its head handed to it a number of times in chess combination and chess competitions with the grandmaster. And really, since that time, computers have dominated chess. It's very, very difficult for the top level competitors and chess grandmasters to compete with most computers and even apps that you can get on your phone. But it is interesting to note that until just recently, humans still dominated a game called Go. If you're not familiar with Go, it's played mostly in Southeast Asia. It's a strategy game similar to chess in some aspects. But in 2017, the world champion Go master was defeated by an AI-based computer. And since then, again, machines have really dominated that. So we see like these little fields of human endeavor, from mathematics to games, that are dominated by computers. I want to make one other reference to the 1990s, and this is a very important time, which was Tim Berners-Lee developed the World Wide Web in the 1990s, and that became the platform on which the data that is used for training AI now would be published. And so, although not in and of itself an AI event, it's definitely an important event in the development of AI. And since then, we kind of entered the era of productive AI. So in 2009, Google's autonomous car was first introduced, and it was the first car that, like, could drive around in some circumstances autonomously. It wasn't great, but it certainly demonstrated a good proof of concept. And in 2011, IBM's computer defeats the Jeopardy champions. And throughout the rest of the 2010s, we saw the emergence of the large language models. And in the 2020s, Tesla's full self-driving introduced, not full self-driving yet in a legal sense, but certainly it's amazing. I actually have a Tesla, and I had the full self-driving trial for a while, and I have to admit, like, it was actually incredibly impressive. So I think it's important to see my perspective and the answer to the question that we're coming to by taking a look at my AI journey and sort of where I came down the road. So my first encounter with AI was a program called Eliza, and you could kind of converse with it. It was supposed to be a psychoanalyst or something like that, that you would type responses into, and you could have this little conversation with Eliza. They were very boring conversations. They were very limited, but I actually had this on my little Sinclair computer in the late 70s and early 80s. But in the 90s, I was working at Pizza Hut, and I was working in the strategic marketing group, and I had graduated from my MBA a few years, about 7 years earlier. And we had an asset at Pizza Hut that very few other businesses had. I mean, other pizza delivery companies like Domino's, et cetera, had it, but Pizza Hut's was the largest. And we knew what your purchase history was. We knew how much pizza you ate, and we could follow along with that at an individual consumer basis, because we just started storing all those data for quite some time. So I data from thousands and thousands of restaurants, and I began learning about segmentation and market segmentation, and using actual consumer data for segmenting the market, rather than like aggregate data, which was all marketers had to work with before that. And what we did was, my predecessor, who created this system at Pizza Hut, had segmented pizza users into cohort groups. So we would study purchase behavior for 90 days, or rather record purchase behavior for 90 days, and you would fall into one of these four categories. You were either a heavy user, double fisting it. You were a moderate user, which was once or twice a month. You were a light user, which was less than once a month. Or you were a non-user, like you didn't purchase any Pizza Hut over the 90 days. So not only did we know when you purchased, we knew when you did not purchase. And we had developed these couponing programs that would actually provide extremely high return on investment to the company. And we had figured out that if I had someone who was for 90 days in the heavy user cohort group, and then they dropped the next 90 days to be non-users, so they went from one end of the spectrum to another one. If I called them up and offered them a buy one get one offer during the week, and I could actually connect them to the Pizza Hut, and we could restart their purchase behavior, and the costs of the calls and the data analysis, et cetera, gave us a return in the hundreds of percentages. And Roger Enrico, who was the chairman of PepsiCo, that actually owned Pizza Hut at the time, he said that it was probably the highest return on investment program he had. And that was just with general stochastics. And that program was running when I kind of inherited the program. But I'll tell you something about me that made this kind of an interesting thing for me. This is my dad. My dad was a rocket scientist, and he was, as you can imagine, extremely good at math. And when we would talk, once in a while about business, et cetera, on the phone. He lived up in Wichita, and I lived here down in Dallas. And he said, "Hey, I think this problem that you have in segmenting consumers is a really good candidate for applying fuzzy logic." And I thought, yeah, normally his PhD level math was beyond my grasp, but this concept made perfect sense to me. And really, best of all, required me not to learn any new math to understand it or implement it. So conceptually, you think about it this: let's say you own a pizza restaurant, and you kind of have a sense of who would respond to a good deal because you know your customers. You don't think of it in mathematical terms like how many purchases or the exact date they last purchased. You think of things like, well, I haven't seen them for a while, but they used to be a great customer. Maybe I should give them a call and offer them a discount, or invite them back in. And after a while, you would kind of learn how much calling is too much, and what kind of person fit the profile. And this is how fuzzy logic is designed to work. So unlike neural networks, which are pretty much black boxes, the rules for fuzzy logic are based on human learning and written in plain English. And so I now had the ability to really focus in on many more customers because I was no longer dividing them into these specific boxes. I could actually predict behaviors of people that behaved alike, and it didn't matter if they had purchased 89 days ago or 91 days ago. I could still figure out how they might behave in the future using fuzzy logic, these rules. And this was a form of AI. And fuzzy logic is actually used as a part of neural nets now as well. But today, so that was back in the 90s, about 10 years ago, the University of Hong Kong showed that really there are just thousands and thousands of electronic products that have fuzzy logic built into them today because it really excels at controllers, and it supersedes really sort of standard algorithmic programming for creating control systems. So that's probably the most common use today, but there are people that do use it in marketing and analysis online. Well, so let's talk about sort of the next step past that, which is neural networks and machine learning. And I don't know how many of you have had a course in this, and I'm not going to go too deep into it, but I'm going to kind of give a real quick level set on neural networks and how they work. And to understand how neural networks work, it's kind of easy to just take a look at a node. So a neural network is conceptual. It's really just lines of code, but it's conceptualized like this. I have two inputs, in this case, 12 and 24. I give specific weights to those inputs coming in to my system. I do some mathematical transformation on that node, and it creates an output. And when I string a bunch of these together, I create a neural network that conceptually looks, something like this. Let's say I've got a couple of inputs. I bring that input into my first layer of nodes, and then it outputs. And this is so simple of a representation. If you look at large language models, they have billions of these nodes. They have a vast number of inputs coming in, but the conceptual process is the same. In order to train my model, I have a list of inputs, and I already know the answers or what I want the system to produce, the output that I want to produce from those inputs. It's called a training set. So I have the solutions on the other end, and I know what I want. And I run the inputs into the system, check to see if the solution is what I want it to be, And then I tweak the weights within the different nodes, those incoming weights and the math potentially in the node itself. It's called the transformer, and I can tell if it's producing the output I want. And so I keep running the data set through there, and I keep tweaking. And I say there's a lot of math involved. The computer does it on its own. It trains itself, but it keeps tweaking those nodes, and it keeps tweaking the weights of those inputs. In fact, you may have heard, that the value of the neural network is in the weights. The weights are, how much do I weigh those inputs as they're coming into the system? And until I get a set of solutions that really checks out. And so once I get a really good set of solutions, and I've kind of purposely divided the bottom part of my inputs because I've saved part of my inputs. I kept them aside. I haven't used them for training. And because I'm going to use them in just a minute. But once I get those inputs to produce those solutions with a great degree of accuracy, then the system outputs a model. And obviously, I've kind of simplified this here, but that's how the neural network learns. And then as a last step, I take the data that I have reserved and I input that into the model, run it through the model, and see, do I get the solutions of the reserved data that I had set aside? And if that looks really good, then that model can be useful. And maybe I'll publish the model. Maybe I'll start using it in production. If not, then I kind of go back through the process and I figure, maybe I tweak the data set, or I tweak the way that I'm kind of changing up the model as we go. So this can lead to some kind of unwanted consequences. And a very famous, I think this is from the 2000s, one of the early neural nets that was looking at photos, was trained on pictures of dogs and wolves. And there were thousands of pictures in the training set. But every time it saw a husky, it would say, well, the husky is a wolf, it's not a dog. And it took a long time for the researchers to figure out why it just could not figure out huskies. They look like dogs more than wolves, at least, as far as they were concerned. Why couldn't they get past this problem? And they finally figured out that what the model was honing in on was the snow, because all of the wolves pictures were shown with a background of snow, and the dogs, the huskies, also had snow in the background. So it was identifying huskies as wolves not because of the dog itself, but because of the snow in the background of the image. So they came up with a new image set. They got wolves not in snow and huskies not in snow, and they were able to train it and make it a lot more accurate. But this kind of highlights some of the issues that we still have today, which is your model's really only good as the training set. So if it lacks diversity, then it might be captured. It might give you a lot of bad responses. There may be biases in the training set, as there were in this case, or the training set may just be too small to really make some kind of distinction. So that gets us kind of to large language models, and large language models like ChatGPT and Grok, and also Claude, and you've heard probably Gemini, a number of other ones that are out there. Meta has a great one called Llama. But the way that the large language models work in kind of a simplified form is that they train a core of that large language model and which is a neural net. And that neural net processes incoming information, whether it's chat, it could be video, it could be audio coming in. It can kind of process just about anything, and it's going to output. But large language models have surrounded themselves with other capabilities. They may access a browser if it says, in order to answer this question, I need to look something up on the internet, or maybe I need to do some math. I'm going to get a calculator out, or maybe I'm going to have a file system that I use, which has some other vectors in it, which will allow me to to kind of look things up. So there's a lot going in large language models, but at their core, they are neural nets. And these neural nets are trained on an enormous chunk of the internet. Recently they've been trained on about 10 terabytes of text. Some of the new models, they're actually increasing that amount, and that's a lot of the internet. That's like a third of the internet. It's quite a bit, at least the publicly accessible internet. And they feed that information into that training cycle I was telling you with questions and answers. But what it's doing is it's predicting what to say next. So it's saying, oh, I'm getting this signal coming in and these 4 words, so what's the next word going to be? This. And large language models are really just guessing like how to respond to you. So they break the data up that way. They feed it into an enormous number of computers. It costs maybe around $2 million to evaluate a model, and it outputs the model itself. In this case, this is for Llama 2, so these numbers are a little bit old. It output 140 gigabyte file. I've recently run one of the more compact Llama models on my local computer. It's very responsive, and it's it's in the gigabytes. The file size is in the gigabytes, but not much more than that. So, nonetheless, it takes a Herculean effort to train the data. So, what about ChatGPT 01? Have you heard ChatGPT 01? Yeah. 01. And so, yeah, the ChatGPT 01 is actually quite impressive. Like I'm starting to, I was a bit, I wouldn't say it was an AI denier or necessarily a skeptic. I just didn't think it was ready yet. And in fact, for many things, it doesn't do a very good job, especially for coding, which is our concern as a group. But ChatGPT 01, even though it's really just kind of going through multiple sets, yeah, Llama 3.2 is on Kaggle. It's an excellent program. It's really just kind of prompting itself. So in other words, it's kind of taking more turns at what it's doing. It takes your input and it sort of comes up with a plan to address that. And then it feeds that plan, it creates inputs, and it reruns it through the model. And those inputs are what bring the output. But it's essentially just going through a number of turns, and this has proven to be very effective for that model. It's definitely increased its capabilities vis-a-vis previous benchmarks. The interesting thing about these benchmarks, however, is that we say things like, oh, well, it can solve 92.8 of PhD level physics problems, or 98.1 of college mathematics problems, and law and formal logic, etc., which is kind of true. What's really going on there is it's submitting 1,000 responses, and one of those responses will be like at least one of those responses is an accurate response to the testing set that's given them. So not really like kind of what you would expect from a human that's an expert in these domains yet, but certainly like improving. So it's making strides, and even strides in writing code. And I'm going to be launching a video on Rosilio's YouTube channel pretty soon, where you can actually watch me write code. It's in the Elixir language. It's actually a Nerves product for an IoT device, and you can see like how to interact with the system, and how to write code with the system. But there are several different ways of writing code. So the way that I'm going to talk about in the video is with chat. And so I'm using a large language model. I'm chatting back and forth with it, and I'm asking it to write code. And it did a reasonably good job of this. I tested the same type of a situation on ChatGPT 4.0, and ChatGPT 4.0, when it produced code, it would produce code. It didn't always run right away. I would have to go through and sort of refactor some of it or update some of the information in it. And it did a passable job, but to be honest, like it took me longer to write the code with GPT 4.0 than it would have by myself, like literally 2 or 3 times the amount of time. So in some situations, maybe it would have been helpful. In some other situations, it would not. In ChatGPT 1.0 or oh 01, sorry, in oh 01, it actually wrote code that ran the first time out of the box. It wasn't perfect. It was pretty good, but this is just one way that you can do it. The big downside of writing code this way is I'm constantly kind of cutting and pasting code back and forth because it cannot access a code base. So it takes a developer who knows what they're doing to kind of communicate with the model and bring in the code and then tell it what to do. So it was slower, but I could have written the code a little bit better than it did in about the same amount of time. So that's a huge improvement. And if they're able to apply some of these techniques to improve beyond that, then it's fantastic. So this is the open source LLMs. And this is another way to do it. Rather than going through like a chat GPT, there's actually a thing called Olama, which has coding functionality built into it. This is Meta AI's model. You may be familiar with Jan LeDuc, who's kind of the head of Meta AI research. And it does a great job, but it only has a few languages that it really specializes in. But you can actually run this model on your desktop. And I have not tested it for code yet. I don't write a lot of Python code, but I understand that it's actually pretty impressive. Another way that developers will interact with OpenAI's or with AIs is through the APIs, where you've got some sort of experience that generally happens like on a device or on the web. That is, information is sent to an API that has a specific training built into it, and then it returns whatever the information is. And as a developer, like this is relatively easy. You're only writing interfaces. You don't even really have to understand what's going on with the large language model, or it doesn't even have to be a large language model, but in many cases it is. But you don't even really have to understand like how that works, because you kind of have these GUI interfaces on the model side that you can deal with, and you're just connecting your production code to the API to get some responses. And then the last way, has anybody here used Copilot from Microsoft? Yeah. So, okay. Now comment, like, have you really intended to be a or have you found it to be successful? Like, do you think, oh, this is great, this is a great tool, it really helps me out? GitHub Copilot, not the Microsoft version, right? Yeah, the coding one, Copilot. I use Copilot image generation. It's great at that. It helps me write my emails. Yeah, not that. I'm talking about the actual GitHub version. Have you used the GitHub version? And okay, helpful with troubleshooting small issues, but making large changes is not ideal. Okay, yeah. You've probably had kind of similar experiences that I have had with it, but as you may know, a number of companies, including the House of Representatives. Now, the House of Representatives is not talking about the coding Copilot on GitHub. They're talking about using Copilot on staff devices, and they have security concerns. But Samsung, Apple, Amazon, and so forth have also put bans of one kind of another on using it for a number of reasons, but that are both concerning from a security standpoint, but also an intellectual property standpoint, because they believe that Copilot is training itself on their code, even though they say maybe they're not. not sure. It's not clear what they're doing with it. Um, and so, that's obviously something. You don't want your intellectual property to be part of the training data. You actually want to benefit from somebody else's intellectual property being used to train it, which is bit of a conundrum, right? But that's kind of how like it's been going along, and it'll be interesting to see if Copilot can sort of overcome these obstacles. But for me, there's just kind of a lot of red flags with AI in general, and the failures continue to be notable. Although I would say that I think the new models are improving, but they're just not there yet. So we have a client that we built an analysis system for, and the system sends out analysis data it's fed into a large language model that then produces summaries in email for the analyst who is our client's customer. And thoroughly tested this. Our client thoroughly tested it. And eventually, after a certain amount of data, the system just started quoting nursery rhymes. I can't understand why this is, but it's really embarrassing, to our client when 25% of their customers were getting nursery rhymes instead of actual analysis emails. So we've kind of gone back to the drawing board on that, but it's really a fault in the model, and there's not much you can do about it, other than kind of figuring out different ways to chop up the data or some other way to feed the data in, which almost negates the whole point of using artificial intelligence to do this sort of drudgery work. It's also unable to work with large code bases, so it will not, produce. Whether it's Copilot or you're working with ChatGPT or whatever. If you have a large code base, you're going to get, you have to be so specific in telling it how to use and how to write formulae and all that sort of thing that probably it's going to be easier for you to write it yourself. There are some limitations to older libraries or versions of languages. It's not up to date, and many languages evolve at a pretty breakneck pace. And so if you're not able to use the latest version, you may be running into some security holes, which is another issue. So I just took Python, for example, and I tricked it into telling me uh, which version of Python it's using, and it's Python 3.12. Now I got to be honest, I have no idea if that's true or not. I don't, and ChatGPT doesn't know if it's true or not. It's just telling me what I want to hear. So I'm assuming that's accurate, but I can't really confirm that it's accurate. But if you look at, there've been quite a few bug releases, since October of last year. There've been 6 pretty major bug releases, one of which fixes a critical flaw that can lead to system and data compromise. And embarrassingly enough, it's in a Python package that can lead to those problems. So, or it's an AI package. So AI is kind of thwarting its own advancement in this case. So in short, there's a number of challenges still left for AI. Don't really need to go over all of these, but going back to our initial premise, Armageddon or business as usual. I'll take you back to Steve Jobs' quote, and the reality is it's a tool. Um, it's sometimes a good tool, sometimes not. It's something else you have to learn as a developer. But in my opinion, you're going to be fine. What you've learned as a developer will serve you extremely well, whether you're using AI as a tool or not, or how much that's becoming a tool, or how much code AI is writing in the future. In fact, learn as much as you can now so that you can be the one using the tool. And my advice is just, ignore the hype. Um, you know, I would listen more to somebody like Mark Andreessen than Sam Altman. Sam Altman's really an investment salesman. He's not he's not a researcher or scientist or really a technologist for that standing. Um, and understand how AI works. That nobody knows everything about it, but understanding the basics. And there are some great people to follow on this. I would look at Andre Karpathy, who was formerly the head of OpenAI. Jan LeCun, who is kind of a bristly person, but he's the head of Meta's AI, and he has some contrarian views on some of the things. But is an AI researcher. He right now he's posting mostly about politics on X, but when he posts about when he does post about AI, it's usually some pretty interesting stuff. Lex Friedman's great to listen to his perspective on things. And go to the LLM company blogs. OpenAI has a blog. Meta has a blog. Google has a blog for their AI stuff. And you can kind of see, what they're looking on. They're usually pretty open about like what's not working in their stuff yet. So I would encourage you to do that and try as many AI tools as you can. Use multiple of them. When the next version comes out, like kind of track to see if it's better than the last time you use it, and you'll get a sense, like Steve Jobs says, of where it's going. But the most important thing to understand is, we're past the days of, well, AI was a fad. This is a part of your future. So I would encourage you to embrace it. And I thank you for attending. I'm going to hang out here as long as they will let me, and hopefully there'll be a way here where I can take some questions. I'll look in the chat for some questions. If you're interested in working with Rizoyo, you can check our careers page and see what's open there. Feel free to reach out to me on LinkedIn. I'm at /n/PW Byrne. And keep an eye on our YouTube channel. We're doing a fair amount of AI content, and we're always talking about developer stuff. So be excited for you to hopefully view some of our stuff. But thank you very much for attending.